guys. Let's go ahead and just make a review of what we did yesterday. Okay, we introduced function. We talk about the function. We talk about the relation. Okay, so to be a function, so we have a two sets. Okay, let's consider we have a two sets here. So we have a set X. We have a set Y. Set X has some elements. Let's say we have A, B, C, and we have 1, 2, 3, and we are trying to find the relation between these two sets. Okay, and we have a function f between these two sets. If so, what do we need to have to be a function? So if f is a function from set X to set Y, then every element from set X has to correspond exactly one element from set Y. Okay, so to be a function, so A has to correspond exactly one element. Let's say it corresponds to 1. C has to correspond exactly one element. Let's say it corresponds to 2, and B has to correspond exactly one element, and let's say that's 3. So here every element from first set corresponding exactly one element from second set, and if this is the case, then we have a function. Okay, and for the relation, to be a relation, every element from first set has to correspond at least one element from the second set. Okay, and what do we call the element from our first set? What do we call every element from the first set? We call it domain or input, right? So element from set X is the domain, or this is input, and the elements from second set, from the set Y, it is range, or we can call it output. Okay, so first set is the domain or input, and the second set is the range or output. Okay, and in general, so our output, so Y is the output. Okay, and our output Y is the function f applied to a element of set X. So our output Y is equals to f of X, or we can call it the function value at X. Okay, so these two are same thing. So Y is the output, Y is a range, and this is same as f of X. Okay, and whatever we have inside the parenthesis, so see here, so this X, whatever you have inside this parenthesis is your input. Okay, so that is your input, or that is the domain. Now let's continue our we still have like two more example. Okay, from number 2. So let's do those two examples, then we'll start the new topic here. So in example number 2, okay, just let me solve here. So we have a function. Our function is f of x equals to x squared minus 1. Okay, so our function f of x is x squared minus 1. So this is a function, and we are asked to find f of square root of 5. So this is number D. Okay, so in number D, we are asked to find f of square root of 5. So here we have a function. So the name of function is f. Okay, so this is the name of function. So our function is f, and whatever we have inside the parenthesis, so we have x. So this x is the input, x is the domain. Okay, and this domain is, and this f of x combined is, so you have your f is a function, your x is a domain, and the combined f of x is, what is this? F of x is the output. This is the y. Okay, so f of x is same as y. Do not get confused. Okay, does anyone need handout here? Okay. Anyone else? Okay, so here our function is f of x equals to x squared minus 1. Okay, and we need to find f of square root of 5. Now in this expression, what is square root of 5? So what is square root of 5? Is it the output or it is the input? is the input. Okay, if you compare f of square root of 5 with f of x, if you compare with f of x, if you compare, for f we have f, okay, for x we have square root of 5, and our x in general is input. We use x for the input, or we use x to denote the domain, okay, and y to represent our output or the range. So here our x is square root of 5. So in order to find the output, what we do here is that we substitute x equals to root 5 for every x in our function. So this is the function. So we substitute x equals to square root of 5 in every x. So we have x square. So for x we have root 5, we have a square -1. So you substitute your input for every x. Okay, your input is square root of 5. Now here, so we have square and square root, it cancel, and we have 5 minus 1, and this is equals to 4. So when your input is square root of 5, so you input is square root of 5, and you get your output as a 4. Okay, and this 4 is a range or a output for this function. Any question number D? Okay, now let's go to the next number, number E, and we need to find f of x cubed. So for number E, you are asked to find f of x cubed. So are we asked to find the domain or a range here? So what are we asked to find? F of x cubed. Are we looking for the input or are we looking for the output? We are looking for the output. Now if you are looking for the output, what is the input here? Our input is x cubed. So whatever you have inside the parenthesis. So this is your input. So you substitute your input for every x in your function. Okay. Our function is f of x equals to, so our function is f of x equals to x square minus 1. So you substitute your input x cubed for every x. So we have f as it is. For x, you're gonna substitute your input x cubed equals, for this x, you're gonna substitute x cubed. Okay, we have a square, so we have a square -1. So you are substituting x cubed for every x. Now here we have a x cubed to the power 2. Okay, both of these are exponent, so we multiply these two. So we have x to the power 3 times 2 is 6 minus 1. So x to the power 6 minus 1 is the output when your input is x cubed. Okay, good with this one? Okay, now I need to erase this one. So we're gonna start the domain and range. Okay, let me go ahead and erase this thing here. Okay, let me start from the very beginning, that we beginning with the function. Okay, so let's say we have a function here. We have a function, our set is x, our set is y. We have a function f, okay, and we have elements -2, 3, 4, okay, and we have 5, 0, 6. So -2 corresponds to positive 5, 3 corresponds to 6, and 4 corresponds to 0. Okay, now if you have a mapping diagram, so this is a mapping diagram for a function. Okay, every element of a first set is the domain. Okay, so every element of the first set, so our domain is collection of every elements from the first set. Okay, so in the first set, what elements do we have? We have a -2, we have 3, we have 4. Okay, so domain is every element from the first set. Our first set is the x, so every element -2, 3, 4, these are the domain. Okay, and every element from the second set is the range. So our range is the set of every element from second set. We have 5, 0, 6. So we have 5, 0, 6. So this is range. So if we have a mapping diagram, the collection of elements from the first set is the domain, and the collection of elements from the second set is the range. So this is the case if we have a mapping diagram. Okay, now let's see a different type of function. So if our function is a set form, okay, so let's say we have a function g, and this function g is a collection of order pair. Let's say we have a -2 0, we have 5 9, okay, we have 10 -15, and we have 0 4. So we have this function g. So g is a function now, okay, g is a name for a function, and this g function is a collection of an order pair, and we need to find the domain for this function, the range for this function. Okay, now this is our set notation for the function, and the domain for this function is every first element of each order pair. So we have a 4 order pair, and the collection of first element of each order pair is the domain. So your domain is first element -2 5 10 0. So all the first element of each order pair is the domain. So we write this domain in a set form. So our domain is -2 5 10 0. So this is the domain, and the range is every second element of each order pair. So our range is every second element of each order pair. So 0 9, okay, -15 and 4, these are the range. So our range is set of second element from each order pair. So we have 0 9 -15 and 4. This is the range. If you have a mapping diagram, the first set is the domain, okay, second set is the range. If you have a set form, if your function is the collection of order pair, then the first element, these are the domain, second elements, these are the range. Okay, now the next type, we might have a function in the equation form. Okay, now if our function is in equation form, let's take an example. So our next function, let's say we have our function y equals to 2x plus 1. So this is a function here, okay, in an equation form. Now we need to find the domain, we need to find the range for this function. Okay, now we have this function y equals to 2x plus 1. Now here domain is, so what represents domain for this function? So our function is y equals to 2x plus 1. What represents the domain here? What represents the domain? X. So x is the domain, or x is the input, and what represents the range here? Y. Okay, output is y or a range is y. So if you have an equation, x is the domain in general. Okay, but you can define, if you want to define your y as a domain, you can do that, but you have to mention that your y is a domain. Okay, but if you don't see if specification that then in general you have to take your x as a domain, y as a range every time. Okay, now here, so this is the equation. Now we have a number, real number. Okay, our real number is from -infinity to +infinity. So we have this real number. So we have the real number from -infinity to +infinity. Okay, now this is the number we have. Now from this number we need to find our input. So what number can we choose for x so that we can get the value for y? So you have a number from -infinity to +infinity. Now we are trying to list every number, every possible values for x such that we get a value for y. Now what kind of number can we choose for our x here? 0. Okay, let's see. So if x is 0, let's find what is y equals to. Our x is input, so 0 is the input. Our output y is, so we have 2 times, you substitute 0 for x, 0 plus 1, we get 1. So when your input is 0, our output is 1. So 0 is the 1 domain, range is the 1. So our domain is 0, range is 1. Now what is the next number? Do we have other number? So you always have the real number, okay? You always have a number from negative infinity to positive infinity. You can choose any number. Now what is the next number that we can choose for our x? 4. Okay, so if x is equals to 4, let's see what is the output. So we have output y equals to 2 times, you substitute 4 for x plus 1. 2 times 4, 8, 8 plus 1, that is 9. So here your x value, 4 is the domain, 9 is the range. Now do we have any other number that we can use for as our input? So that's right. So we can use any number from negative infinity to positive infinity. It does not matter what number you choose, we always get an output. We always get some real value for y. And if this is the case, then all real number is a domain for this function. So for this function, okay, our domain, so this is our linear function. So the domain is every number from negative infinity to positive infinity. That is from negative infinity to positive infinity. What it means is that whatever number you choose from this domain, you get output. You can always get some real number as the output. Okay? Now, what about the range for this function? So here range means, so we know what is our input, right? So our input is all real number. So when you use all those real number as your input, what kind of number do we get as our output? We might get any number, right? So all real number is the range. So from negative infinity to positive infinity is the range. So whenever you are asked to find the domain, you are looking the values that you can choose for the x, okay, so that you can get the value for y. You have to get the real value, okay, then those are the domain. And the range is, once you have the input, what are the possible number that you get from the input? They are the range. Okay, now we do have some more examples here. Okay, these two are easy, okay. So when your function is in the mapping diagram and the set, it's pretty easy finding the domain and range. But whenever your function is in the equation form, we need to work extra here, okay. Now let's go to our example here. So in example A, we have a function g of t, okay. So our function is, g of t is equals to t square plus 4. Now what is the name of function here? So g is the name of function, okay. Now what is this t for this function? T is the input, okay. So it's not that every time x is the input, okay. So it depends how we have defined. So whatever we have inside this parenthesis with a function is your input. So t is the input, okay. And if t is the input, so what is g of t together? That's the output, that's the range, okay. Now, and this output is given by t square plus 4. We need to find the domain for this each of this function. So finding domain means what kind of number we can choose for t so that we can get the value for output, we can get the real output. And your number is, your option is from negative infinity to positive infinity, okay. You can always choose any number from negative infinity to positive infinity. So this is the option that you have. Now from this set, we have to list every possible number that we can choose for t so that we can get an output. Now what kind of number we can choose for a t? Okay, let's choose t is equals to 0. If t is equals to 0, then g of 0, which is the output, is equals to, so you're going to substitute 0 for every t. So we have 0 is square plus 4. 0 square is 0 and plus 4 is 4. So we have 4. So here, when your input is 0, we have an output. We have a real number output. It means 0 is one domain. Okay, now do we have any other number from our real number? What other number we can choose here?
Any number.
So can we choose any number like a fraction, decimal, square root of 2? Can we choose any number? What about square root of 2? Let's see. So can we have t equals to square root of 2? So if t is square root of 2, is this a domain or not? Let's see. So we find g of, you substitute square root of 2 for every t in this function. So g of square root of 2 is equals to, you have square root of 2 square plus 4. So 2 square root cancel, you have 2 plus 4, we get 6. So when your input is square root of 2, we have a real output. It means square root of 2 is also a domain. So you're gonna list every possible values for x that give us output, and all those values of x are here. We have a t, okay, all those values for t which give us the output is the domain for this function. Now can we choose any number from a real number as a value for t? We can, right? So it means every real number is a domain for this function g. So your domain is every real number that is from negative infinity to positive infinity. Okay, so you are not required to show all these. Okay, so if you have the function, you can just directly write. If you know this is the domain, then you can just write directly this as your final answer. So every real number is the domain for this function. So what kind of function is this? Is it a linear function or quadratic function? So this function g of t. So to be a linear, the degree has to be 1. Okay, but we have a degree 2 here. Okay, see that t has a exponent 2. It means it is a quadratic function. Okay, we'll talk in detail about quadratic function. Okay, do you have any question with this number A? You are only asked to find the domain. Okay, so we don't need to worry about the range. Okay, now let's go to the number B. So our next function is f of x. Okay, so we have a function f of x, and f of x is the square root of 4 minus x. So this is a function. So here, what does f represents? F is a name for a function. Okay, and what is this x for this function? Input. And the f of x combined is the output, and f of x is equals to square root of 4 minus x. We are asked to find the domain. Now your option is you're gonna list every number from negative infinity to positive infinity. Okay, this is the option that we have. Now what kind of number we can choose for x such that we get the real output? That is the question.
Negative infinity to 4.
Okay, so what about negative infinity to 4? Okay, let's see that. Okay, so let me choose. Okay, just pick one number from this real number. Can you just pick any one number? Let's see that is a domain or not. Give me a number. 4. Okay, so if x is equals to 4, let's see what happens. If x is equals to 4, now you substitute 4 for every x in this function. We have f of 4 equals to square root 4 minus 4. You substitute 4 for x. So we have square root of 0. And what is the square root of 0? It's a 0. Okay. So whenever your input is 4, we have a real number output. We have an output 0. So it means 4 is a domain. Yes or no? 4 is a domain. That's right. So we have one domain 4. Now let's find the other domain. So what number do you want to pick here? Let's check.
6.
Okay, let's see if 6 is the domain or not. If x is equals to 6, if your input is 6, then we substitute 6 for every x. So f of 6 equals to square root. So we have 4 as it is, minus x is 6. So we have square root of negative 2. And what is the square root of negative 2?
Imagination.
Is it a real number or it is an imaginary number? So it's a complex number, imaginary number, right? So here, whenever you choose your input to be a positive 6, your output is not a real. It means 6 is not a domain. So 6 is not a domain here. So to be a domain, you have to get a real number as your output. Like whenever you choose your input to be a 4, we get our output 0. 0 is the real number. So 4 is the domain. But whenever our input is 6, we had a complex number. We had an imaginary number as our output. That's not what we want. We want to be a real output. Then only our input is a domain. So here 6 is not the domain. Now, what are the other numbers which are not a domain here?
Anything less than 4.
So any number less than 4 is a domain or is not a domain? So any number less than 4, let's take positive 1. Is a positive 1 domain for this function? Yes. Okay. What about negative 4? Is negative 4 domain? Okay, you can always check. Okay, so what you can do, you can choose your input negative 4 and you find f of negative 4. You substitute negative 4 for every x. We have square root 4 minus your x is negative 4. We have square root 4 minus times minus 4, positive 4 equals to square root of 8. And this is a real number, right? We get a decimal. So it means whenever your input is negative 4, we have a real number as our output. It means negative 4 is a domain. Okay? Now, here, what kind of function is this? Can you try to name this function from this expression? What would be the name for this type of function? Radical function. Okay, and let's be more specific. We have a square root, so this is a square root function. Okay, and if you have a square root function, okay, so let me write you in general. If your function is square root function, okay, and this function is defined, okay, so your x has to be whatever number you have under this radical sign, it has to be 0 or greater than 0. Then only we can have a real solution. Okay, if this x is less than 0, like here, see your x is negative 2, it means the radical is undefined. Okay, whatever you have the expression under the radical expression has to be 0 or greater than 0. So to find the domain for the square root function, so what you're going to do here is that you are not required to do all these. So if you have a radical function or a square root function, then you need to solve the inequality. Your expression, whatever you have inside the radical, we have 4 minus x. Okay, whatever you have inside the radical, we have 4 minus x. This has to be greater than or equals to 0. Then only we can find the real output. Okay, so if you have a square root function, so you just write down whatever you have under the radical sign. Okay, we have 4 minus x and greater than equals to 0 every time. Okay, now if you have a number under the radical 0, then we can know that is 0. If you have a positive, then we can find the real number. Like for example, so here we have a 0, here we had a positive 8. Okay, so if we have a number under the radical greater than or equals to 0, then we can find the real output. Now this is the inequality. We need to solve this for x. How do we solve? So we have 4 minus x greater than equals to 0. How do we solve this inequality? Solving means we are making x by itself, right? So we have positive 4. Let's get rid of positive 4 from left side. So we subtract 4 on both sides. Okay, so positive 4, negative 4 is 0. We have negative x greater than equals to 0 minus 4. That is minus 4. Now we still have a negative in front of x. How do we get rid of negative? Divide by negative 1. And what happens if you are dividing the inequality by negative number? The inequality sign flips. That's right. So we have negative x divided by negative 1. Positive x. Now it flips to less than equals to negative 4 divided by negative 1, positive 4. So every number which is less than or negative 4, so your x has to be less than or equals to 4, and every number which is less than or equals to 4 is the domain for this function. And we need to write in an interval notation. Okay, to write in an interval notation, you can draw a number line. So we have negative infinity, positive infinity. So we have a number 4. So let's say we have number 4 here. So at 4, is it a closed circle or open circle? Closed, because we have equals to here. So we're going to have a closed circle at 4. Now, where do we find a number which is less than 4? On the left or on the right? Left. So all the way to the left. Okay. So our domain for this function is from negative infinity to all the way positive 4. With negative infinity, it's always parenthesis. And at 4, we have a closed circle. It means we're going to have bracket. So every number which is less than or equals to 4 is the domain. It means whatever number we choose from this set, we get the real output. But if you choose a number which is not on this set, we do not get the output. Okay, like for example, if you choose x equals to 10. Okay, if you choose x equals to 10, 10 does not give us output. So what happens if x is equals to 10? So we have square root of 4 minus 10. So we substitute 10 for x. So we have 4 minus 10, and this is square root of negative 6. This is a complex number. This is not a real. So 10 is not a domain. Okay, but every number which is in this set, negative infinity to positive 4, is the domain for this function. And if you have the square root of a square root function, this is what you're going to do. Okay, every time you just write down whatever you have inside the radical sign greater than equals to 0, and you solve that inequality and you get the domain. Okay, this is the case when we have the square root function. Good with this one? Okay, let's do one more similar. Okay. Okay, can you find the domain for a function f of t equals to square root of 3t plus 4? What will be a domain for this function? Your function is f. Okay, t is the domain. That's what we are trying to find. And f of t is the output. And your output is given as square root of 3t plus 4. Now you have the option to choose a number from negative infinity to positive infinity for t. Now what kind of number we can choose for t? Okay, let's try. Okay, if t is negative 2, can we choose negative 2 for t? Okay, if t is negative 2, then you substitute t equals to negative 2. We have f of, in this function, okay, you have f of negative 2 equals to square root 3 times negative 2 plus 4. So we have 3 times negative 2 is negative 6 and plus 4. So negative 6 plus 4 is negative 2. And is this a real number, square root? No, it means if your output, this is the output, and if your output is not a real number, what can we say about this input? Is this a domain? This is not a domain. So negative 2 is not a domain, but we are trying to find the domain here. So what kind of number we can choose for t so that this function is defined? So here, what you're going to do here is that you're going to write whatever you have under the square root. So we have 3t plus 4. So we have 3t plus 4. And this number, okay, so this is a number. So 3t plus 4 is a number. And this number has to be 0 or greater than 0 to have a real number. So 3t plus 4 has to be a 0 or greater than 0. Then only we get a real solution. Now we have this inequality. We need to solve for this inequality. And the solution is the domain. Now how do we solve this? So you subtract 4 on both sides. Positive 4, negative 4 cancel. So we have 3t greater than equals to 0 minus 4 minus 4. Okay, we need to get rid of 3. So we divide both sides by 3. And if we are dividing by positive number, inequality remains same. Okay, it does not change. So we have 3t divided by 3, that is t greater than equals to negative 4 over 3. So what it means, your t has to be greater than or equals to negative 4 over 3. So if you have a number which is equals to negative 4 over 3 or greater than negative 4 over 3, then we get a real solution. Okay, so it is a domain. Now how do we write in an interval notation? So you draw a number line. So you have negative infinity, positive infinity. Let's say we have negative 4 over 3 here. Now at negative 4 over 3, is it a closed circle or open circle? Closed, because we have equals to here. So we're going to have a closed circle. Now, is t is greater than negative 4 over 3? Is it on the right side or on left side? Right of negative 4 over 3, right? So all these numbers are the domain. So we have negative 4 over 3 all the way to the positive infinity. So we have a closed circle at negative 4 over 3. It means we're going to have a bracket and we have a parenthesis with infinity. And this is the domain. So every number which is greater than or equals to negative 4 over 3 is a domain for this function. So what it means? Now from here, can you tell me, is negative 5 a domain for this function? Okay, and what is the reason? The negative 5 does not belongs to this set, right? So this is a set of domain, and we don't find a negative 5 in this set. It means negative 5 is not a domain. What about 100? Is 100 domain for this function? Yes. Okay. Any question on this one? So every time if you have a square root function, what do? You just write down whatever you have under the square root and greater than equals to 0. You solve that inequality. Solution is the domain. Okay. Now let's go to the next example. So the next we have is number C. Okay. Let me erase number. Okay. Now here. So I'm going to erase this part here. Okay, what kind of function is number C? Can you try to name it? So our C is h of h. So this is a function is h. So we have h of s equals to 1 over s minus 1. 1 over s minus 1. Okay, now here. Okay, what is this h? That's the name of our function, right? Okay. What is this S? That's the input or our domain. Okay. S represents the domain here. And H of S command is the range or output. And this output is equals to 1 over S minus 1. Okay. We are asked to find the domain. So finding domain means what kind of number you can choose for S. And the option is from negative infinity to positive infinity. So this is what we have. So we have this list. Okay. Now what kind of number we can choose for S so that we get our real number as an output?
Since it's a fraction, the bottom part cannot equal to 0.
Okay, that's right. So it's a fraction. We can't have a 0 in the denominator, right? So what happens if we have a denominator equals to 0? So if you have 1 divided by 0, what is that equals to? That's undefined. Okay, we can't have 0 in the denominator. Okay, so this is a so we have a fraction here, and we also call a rational. This is a rational function here. Okay, now if we have a rational function, we can't have a 0 in the denominator. Okay, now what number makes our denominator equals to 0 here? So for what s value our denominator is 0? 1, right? So when you choose s equals to 0, let's see what happens. So when you choose s equals to 1, then let's see our output. You substitute 1 for every s here. So we have h of 1 equals to 1 divided 1 minus 1. So we get 1 divided by 0, and 1 divided by 0 is undefined. Okay, this is not a real number. So this is undefined. So it means, what can we say about the 1? Is it a domain? No, this is not the domain. So 1 is not a domain for this function. But what about other number? Can we have any other number for s and we get the output?
Yes.
Like a fraction, decimal, square root?
Yeah. Two.
Okay. Now what about the negative number? Can we have a negative number for s here? Let's try. Okay, let's take one negative number. So let me pick s equals to negative 5. Let's see what happens. So you substitute negative 5 for every s. So we have h of negative 5 equals to 1 over negative 5 negative 1. We have 1 over negative 6. Now is this a real number? It's a negative fraction. It's a real number. It means, so if you have a real number as your output, that means your input has to be a domain. So negative 5 is a domain. Okay. So in this function, we can have any number other than 1. Okay. So every number other than 1 is a domain for this function. So if you have a denominator, if you have a fraction as a function, then the number that makes your denominator equals to 0 is not a domain, but any number which does not make a denominator equals to 0 is the domain. Okay, so in this case 1 makes denominator equals to 0, so all real number other than 1 is not a, sorry, is a domain. Now how do we write in an interval notation? So we draw a number line. So we have positive infinity, we have negative infinity. What is not a domain for this function? What number is not a domain? So we have 1. Let's see, 1 is not a domain. Now if 1 is not a domain, we are trying to exclude 1, right? So if we are trying to exclude 1, do we use a closed circle or open circle? It's gonna be open circle. Okay, so if you are including, you're gonna use a closed circle. If you are excluding, you're going to use the open circle. So 1 is not a domain. So we are excluding 1. So it means we're going to have a open circle. And for this function, we can have any number on the left as our domain and any number on the right as our domain, but we can't have 1 as our domain. Now let's write this in an interval notation. So we have from negative infinity to 1. So with an infinity, it's always parenthesis. Now what about with 1? Is it a bracket or a parenthesis? Okay, because we have a open circle, because we are excluding. So we're going to have a parenthesis. Now let's write the interval notation for this part. So it's starting from 1 all the way to the positive infinity. We have parenthesis with the infinity. We are excluding. It means we have a parenthesis here. That's okay. Now why is a union?
Because
So can we have, so we can have a number from this set or this set. Okay, so we have or, and or is the union. Okay, so this is our domain. So our domain is from negative infinity to 1 union 1 to infinity. If we have a fraction, the number that makes your denominator equals to 0 is not a domain, but any other number will be a domain for this function. Good? Okay. Now let's do the last example. Do you have any question on this one? So when you have the square root function, what are you going to do? You're going to write whatever you have under the square root greater than equals to 0, and you're going to solve that. Okay, when you have a fraction, when you have a rational, you look a number that make denominator equals to 0, and a number that makes denominator equals to 0 is not a domain. Okay, now let's see what we have in the next. So we have, okay, number d, and our number d is, okay, just let me solve here. So our function is h of t equals to 1 over 4 square root 4 minus t. Now we have a fraction, we have a square root. So it is a combination of B, and C. Now here, so what is this H? This is a name of function, right? And what is the domain here? T. T represents the domain and H of T is the output. So we are asked to find the domain. It means we are listing a number for T so that we get a real number as the output. Now we have a fraction here. So if we have a fraction, what we can't have? We can't have 0 in the denominator, right? We can't have 0 in the denominator. And the next thing, we also have a square root. If we have a square root, what we can't have under the square root? We can't have a negative number. So we have to keep in mind. So we have a fraction here, okay? So our denominator is square root of 4 minus t. This can't be equals to 0. Okay, next thing, we have a square root. And if we have a square root, whatever we have under the radical sign, that should not be a negative number. That should be positive number. Okay, now how we gonna find the domain for this function? So what are the number we can choose for t? Can we choose t equals to 4? What happens if t is equals to 4? We get 0 in the denominator, right? So 4 is not the domain. So what about 5? Can we choose t equals to 5? We get, if t is 5, then we have 4 minus 5, square root of minus 1, which is not the real. So we can't have this. Now, so what you're going to do here is that the number that we have under the radical, so this is what we have under the radical, this number has to be greater than 0 or it has to be equals to 0. Can we have 4 minus t equals to 0? What happens 4 minus t equals to 0? We have a square root of 0 and we have 1 over square root of 0 is, that's undefined. So in this case, okay, if your t is 4, let's see, we have 1 over square root of 4 minus 4, we get 1 over square root of 0 and that is 1 over 0. This is undefined. It means this is not a domain. Okay. Similarly, we can't have a 5. So if you choose t equals to 5, then we have 1 over square root 4 minus 5. We have 1 over square root of negative 1. This is not a real number. It means we can't have this number as a domain. Now do you have any idea what would be the domain be?
Negative 4, infinity to 4, all in parentheses.
It has to be a number less than 4, right? Or what you can do is that here, this 4 minus t. So we have 4 minus t under the radical sign. This number has to be greater than 0. Okay? So whatever we have under the radical sign, this number has to be greater than 0. It can't be equals to 0. Okay? If it is equals to 0, we're gonna get undefined. So it has to be strictly greater than 0. This is the inequality. Now let's solve this. So you subtract 4 on both sides. So this cancel. We have negative t greater than negative 4. Now how do we get rid of negative? We divide by negative 1, right, on both sides. So we have negative t divided by negative 1, positive t. Since you are dividing with a negative number, you're going to flip this inequality. So we're going to have less than positive 4. So in a number line, so you have positive infinity, you have negative infinity. So we have 4. And at 4, is it an open circle or a closed circle? It's open because there is no equals to sign here. Okay, it's only strictly less than. And since it's a less than, it's on the left side, right? So any number, our domain is from negative infinity to positive 4. We have a parenthesis at negative infinity, and since it's an open circle, we're gonna have a parenthesis here. Okay, so negative infinity to 4 is the domain for this function. Okay, our 4 is not a domain. Okay, if your t is 4, we get 0 in the denominator. So that is not the domain. Okay, all right. Let's do this much for today.